Okay, so hello. Here I wanted to answer some homework questions that people emailed to me, and it's much easier and really only possible to do it here in video format. So the questions were about number 4, 5, and 6. And 4 said, use the expressions for left and right sums on page 244 in table 5.5. Well, here's table 5.5, and that's a data table, like a time and velocity curve, like we had for our examples, and I'll be right back. Sorry, I forgot to close my door. Okay. Anyway, so this is the data table. So what we did before was we simply made a little graph of that. So I'm going to do that here. Here is, it goes, as you see, from 15 up to 23. So 15, 16, 17, 18, 19, 20, 21, 22, 23. So 15, 17, 19, 21, and then 23. And the time and then the function values go from 10 up to 30. So let's say 10, and I'm going to slide this out of the way just a minute so that I've got more room, and we'll bring the question back in a minute. But let me finish graphing this here. So so that we're just looking at the data there. That goes up a little bit. So that'll be 10, let's pretend. Okay. Well, I don't know. Let's start out at 0, so it's realistic here. 10, 20, 30, like that. So this is going to be 10. This is going to be 20. This is going to be 30. Just so, right? And then what we do is at each of these function values, we plot the data. So at t equals 15, it was equal to 10. So I'm going to put a dot right there, right? I'll even use a different color here. Use this one right here. Right? Okay, and then at 17, it's equal to 13, so that's probably about there, right? And then at 19, it was equal to 18, so that's about right there. And then at 21, it was equal to 20, so that's about there. And then at 23, it goes up to 30, so that's about there, right? So we did this visually before, because this is going to be kind of important to us to be able to see the visual parts of this. So we had, in effect, that function that kind of looks something like that, right? Okay. Now, we're finding they're asking for here, and you should be looking at this hopefully in your book too. They're looking for the left and right sums. So what we've got to do is we've got to divide this into rectangles. Now what they want is if n is 4, what's delta t? Well, remember delta t was the division down here when we divided it into into rectangles here. Right? And that was the width along the bottom. We'll label that in a minute. I'll slide this back down here. Okay? So T0, that was the first T number. So that's T0, that's T1, that's T2, that's T3, that's T4. These are the corresponding function values, right? That would be f of T0, which is 10. F of T1, which is 13, F of T2, which is 18, F of T3, which is 20, and F of T4, which is 30, right? Now, so that's what those are. And what they want you to do, they've got these values here, because you see, once we look at the curve, they divided this thing. When we get the area under the curve, when we get these sums, we've got 4 intervals. 1, 2, 3, 4, right? And each one of those, that's the delta t. And you can see here they skip 2. So delta t, when n is 4, delta t is 2, right? And you can see that just from the data. But the formulas that they refer to had to do with this formula here, was that we would, in order to find out what delta t is, we would take note of, I'm going to come up a little bit here so we've got more room so you can see more. Okay. We would say, okay, we want n to be equal to 4, and we want this interval, this function interval from 10 up to 30, from 15 up to 23 to be divided into 4 even intervals. Why? Because n is 4. So we subtract 23 minus 15, right? So that's the, in this case, it's going to be what they called T4, or the biggest, sorry, there it is, wow, zoomed in more than I thought. Sorry, here we go. So this is, focus again, there we go. So T4, that was equal to 23 on the graph. That's here, right here. It's tiny now. That's 23. And then T0, that's the lowest, was 15, right? So we did the upper T minus the lower T, because remember, we're dividing this bottom, this T-axis here, into even intervals. So we did 23 minus 15, and then that's divided by 4, because we wanted 4 intervals. Okay, so that's 23 minus 15 is, that's 8, divided by 4 is equal to 2. So that says that, t is equal to 2. Does that make sense? Okay, so find the left and the right sums using n equal to 4. Well, okay, so down here we go from 15 up to 23, okay, like this, 15 up to 23, right? And then we've got 4 intervals every 2. So 15 up to 17, 19 up to 17 up to 19, 19 up to 21. In other words, that's the first interval, that's the second interval, that's the third interval, that's the fourth interval, right? Now, since we want the left hands, now they want the left and right sums. So the left sum means I'm going to go up to, I'm going to make the rectangle that's anchored, or that starts from the left boundary of each of these intervals. So that's going to be over here. So I go up to where the left boundary hits the axis of the curve, hits the graph of the function at 10, and I read over and I draw over there to make the rectangle. And that's this rectangle right here, right? And then up to, at the other left boundary of the next interval, up here. And I make the rectangle over, right? And then up to the next interval, I go up to the left boundary here, like that. And then lastly, the left boundary for the last interval up to here. And now, since they gave the data to us on the table, there's no need for us to try to read this little sketch graph we made, because you can see that for each of these, 2 is the width, and the left boundary height, that's the height. Okay, so that's going to be from the table here. So this is the left, right? Two times 10, 2 times 13, 2 times 10, 2 times 13, which is that number right there, 2 times 17, which is this number here, and then 2 times 19, that's this number here, right? So we used the 15, the 17, the 19, and oh yeah, we 15, 17, 19, and then 2 times, sorry, I'm looking at the wrong numbers. 2 times 10, 2 times 13, this is 2 times 18, because that's the height at 19, and then 2 times at 21, the 2 times the 20, right? And so this gives us the left hand, what we call the left hand sum, right? And we added those all up. That's, this time of day, it's calculator time for me. So 20 plus 26 plus 36 plus 40, that is 122. That's the left-hand sum. All right? And then you can see here somewhere on page 1, whatever that was, 244, they said, oh, if we want the left-hand sum, use the first 4 left-hand numbers, right? But I just think it's easier to see what's going on if you draw the picture, right? Okay, the right-hand sums, okay, what we do is we do the same thing again, except we're going to use, when we connect our rectangles, we're going to use the right-hand boundaries. And for this one, that's going to be 13, 18, 20, and 30, right? So that would be, to make the right-hand boundary, the right-hand rectangles, I use the right-hand boundary of each interval. So that's going to now be that rectangle, that rectangle, that rectangle, and that rectangle, right? Which means that we're going to use the same delta t intervals, but we're going to use 13, 18, 20, and 23. 13, 18, 20, and 23 to be our heights. So here it's going to be for the, and this is for the right-hand one, 2 times 13, 2 times 18, 2 times 20, and then 2 times 30, 26, 36, 40, and 60, and that's looking a lot like 162. Yeah. So that's the right-hand boundary. Okay, that's the right-hand sum. Okay, does that make sense? All right, good. Now, they want you to do it again, except with n is equal to 2. Now, I'm not going to go through that because it's exactly the same process, but now it's actually going to be a lot quicker because actually we're only going to have 2 boundaries or 2 intervals, and so therefore only 2 rectangles. So real quick, I'll pull that out. Okay. Another quick graph here. So this is 15, 17, 19, 21, 23, 10, 20, 30, right? And then we had, the thing was at 10, then it was at 13, then it was at 18, then it was at 20, then it was at 30. So we had the same function graph, and we're getting the right and left hand sums still from 15 up to 23, but now we want 2 boundaries or 2 intervals. Well, it's still going to be 23 minus 15. So here n is equal to 2. 23 minus 15, we're still spanning, a horizontal distance of 8, a horizontal time of 8. We want n is equal to 2. So divide by 2. So that means that each of these intervals, and you can't see that, oh, there it is, n is equal to 4, right? So now you can see that, oh, how convenient, just visually, that means we're going to divide this at 19, right? 15 up to 19 and then 19 up to 23. So this is two boundaries. Oh, so and so you can see now that delta t is equal to 4, right? Because this is the delta t here. And so we would call this T0, T1, and T2 if we wanted to renumber them. Okay, but we're going to use the same data. Now, and I'll just do the left-hand one, which is here. Okay, we're going to take the first interval as this one here. So the left-hand sum is just like that, right? There's the rectangle for the left-hand sum. And then to get the left-hand rectangle for the second interval, we go up to its left-hand boundary right there. Okay? And we can see, oh, using again the data in the table here, 15 to 19, we're using the left-hand boundary, so we're using the 10, right? So that would be 4 times 10, because this is 10 high, you understand. And then this one is the 19, at the 19 data point, so 18 is how high that one is. So 4 times 10, and 4 times 18, that's 40, and then that's 4 times 18 is 72, and that's 112. Okay? All right, so that's how that goes. And then the right-hand sum, I won't do that one, but that's using this rectangle here and, oopsie, that rectangle there, right? Calculate using this height and this height. This data point and this data point. Yeah, this data point and this data point for the heights. Okay? And so that's how that goes. That's number 4. Now, number 5 is done exactly the same way. Okay? It's just an odd version of that. Let me just see here. So number 5 is exactly the same. Okay? And so hopefully that answers your questions here. Okay? Now so that's number 4, and I'm going to post that online here along with right underneath this video. Okay, then I think someone was asking about number 6, right? So let's see for number 6. Okay, I'll slide it down here on page 246. Left and right sums, okay, oopsie, don't see all of it. Oh, there it is. At time t is equal to t in seconds, your velocity v in meters per second is given by that formula. T is between 0 and 6. So in other words, on the time interval from 0 to 6, we want the area, the distance that the car would travel, or whatever it is, from 0 to 6 seconds. If this is its velocity function there, they want delta t is equal to 2 to estimate the distance traveled during this time. Find the upper and lower estimates, then average the two. Okay, so that's really just like number 4 here, you understand, except instead of giving you the data table for 0 to 6, they gave you the function, which we would use to get the values. Okay, so let's see. So for number 6, let me fold this one over here. Okay. Right? So, we're still going to plot a graph to visualize this, you understand. So we want v of t is equal to 1 plus t squared, and we want it on the interval from 0 less than or equal to t less than or equal to 6. So we're going to plot the graph, right? And to do that, we're going to make a t table. we're going to use the interval values they give us. Okay, you cannot see that. Sorry. Here we go. Got to make it bigger now. So if you're having trouble seeing this, you better go look in your book, okay? Seeing the problem. Now we figure out the function values. This is, write these here. This is going to be 1. This is going to be 2. 2 squared, that's 4 plus 1 is 5. That's 10, right? 4 squared is 16 plus 1 is 17. 5 squared, 25, that's 26. 6 squared, 36 plus 1 is 37. So you understand, here's a data table with T0, T1, T2, T3, T4, T5, T6. And this is f of T0, f of T1, f of T2, f of T3, f of T4, f of T5, f of T6, yeah? Now, we plot those. 0, 1, 2, 3, 4, 5, 6, right? And that goes all the way up to 40, so 10, 20, 30, 40. Okay, again, this is a sketch because the data values that we're going to need to do this are actually in the table, right? So, 0, 1 about, over 1 up 2, yeah, over 2 up 5, over 3 up 10, up 4 17, 26, and then 37, might be right about there, right, and there's our V of t right there, right? Now, they want left and right sums for n is equal to 2, right? Or rather, sorry, I'm reading that wrong. Delta t is equal to 2. That means we want to split this interval from 0 up to 6 in intervals that are exactly 2 wide on the bottom here. Well, maybe you can see that. That would mean that zero to 2, 2 to 4, 4 to 6. So we get delta t is equal to 2 for each one. Formally, if you're using the formulas that they mentioned, we would see here that we're still stretching from 0 up to 6. So we're still going to do 6 minus 0, right? But it tells us we want delta t is 2. So I'm going to divide by delta t this time. And that tells us, oh, n has to be 3 intervals. 1, 2, 3, right? Because the width of the interval times the number of interval equals the total elapsed span on the x, in this case t, right? So now what do they want? Oh wait, actually, yeah, n is equal to 2, right? So that means we've got 3 intervals, right? Yeah, so let's see here. So we're going to go ahead and do the left-hand one. Okay, you know what? Actually, for yucks, I'm going to do the right-hand one this time. Okay, so the right-hand one is going to be the upper, so they say the upper estimate and the lower estimate. Well, they want the lower estimate means the one where the rectangles are going to be below the curve and there'll be leftover area. Something that's going to look like this, in other words. Those are the left-hand estimates, or those are the lower estimates, because they'll give you areas that are below, right? And in the case of an increasing function like this, those are going to be the left sums. So we would get, to get the lower estimate, we would use the 3 rectangles here to get the left sum. To get the upper estimate, that means we're talking about the rectangles for each interval that are overestimating or protruding above the curve that we're trying to get the area under. So that means this rectangle here and this rectangle here. This is going to give us the upper estimate, in other words, also aka the overestimate, and then we would find, so that means we're finding the right-hand sums here. Okay? So for instance, on this one, the right-hand sums, delta t, for the right-hand sums it would be, okay, 2 wide, and we want the left-hand boundary is at t is equal to 2, so that's 5. So 2 times 5, I'm getting a 5 over here. The right-hand boundary for the second interval is at 4. So and the v of t value is 17. So that's going to be 2 times 17. And then the right-hand boundary for for the third interval is going to be is right there at 37 high. 2 times 37. So that's 10. That's 34. And then this is 54, right? No, 74, right? 2 times 37, 74 plus 34 plus 10 is 118. So that's the left-hand sum. That's the upper estimate or the overestimate, right? And then to get the lower, the under, we would go ahead and we would get my purple rectangles here, which gives you the left-hand sum, which is the lower. Does that make sense? Okay, so one last word here to make sure, it's getting kind of long here, to make sure we understand. If it were a decreasing function, okay, and then, oops, you cannot see that. If this were a decreasing function, like this, then the right-hand sum would be getting you the underestimate, and the left-hand sum would be getting the upper estimate, right? So whether the left-hand sum or the right-hand sum gives you the upper or the lower estimate depends on whether you are increasing or decreasing. So you got to pay attention to that. So then they asked, once you've got the lower estimate, which would be less than this, oops, here it is. Once you've got the lower estimate here, you'd go ahead and you'd add them together and divide by 2 to get the average, which the idea is would give you a better, either one of them would, that average would be a better estimate for what this upper and lower, for what the actual area under that curve is between 0 and 6. Okay, well, that's enough. I hope that helps. If not, I'll see you tomorrow at 11 o'clock for our video conference, our class video conference. Bye.